In this section we're going to talk about exponents and radicals, and if a is any real number and n is any natural number, that's a positive integer, the nth power of a is defined as a times a times a, where we have n factors in that product. So for example, minus 2 to the 3 is equal to minus 2 times minus 2 times minus 2, which equals minus by minus gives me a plus 4 times minus 2, which is equal to minus 8. And 2 to the 4 is equal to 2 times 2 times 2 times 2. You see we multiply it by itself 4 times. And that's equal to 2 times 2 is 4 times 4, which is 16. And this might be a good time to pause the video and try to figure out what these other powers are. Okay, hopefully you've tried to do that, and now we'll look at minus 1 to the 5. That's minus 1 times minus 1 times minus 1 times minus 1 times minus 1. And we see minus 1 times minus 1 is 1, so this is 1 times minus 1, which is minus 1. And in fact, you'll see that minus 1 to the n is equal to minus 1 if n is an odd integer, an odd positive integer. Minus 1 to the 4, on the other hand, is minus 1 times minus 1 times minus 1 times minus 1, and this is 1 times 1, which is 1, and you can also figure out that minus 1 to the n is 1 if n is an even integer. Let's try a fraction, 1 over 3 to the power of 3. According to the definition, this is 1 over 3 times 1 over 3 times 1 over 3. And now using the rules of fractions, this is 1 over 9 times 1 over 3, which is 1 over 27. And 0 to the power of 3 is equal to 0 times 0 times 0, which is of course 0. That's how we define a to the n, where a is any real number and n is any natural number, a positive integer, or a counting number. A is called the base, and n is called the exponent or the power. Now suppose we want to extend this definition to include exponents which are either 0 or negative integers. Then we have to think about some restrictions. We have to restrict the possibilities for the base to non-zero real numbers. So in other words, we cannot define 0 to the 0 or 0 to the minus 1. So if a is not 0 and it's a real number and n is a positive integer, then we define a to the 0 as 1, and we define a to the negative n is equal to 1 over a to the n. And notice we've already defined a to the n, so this is a pretty sound definition. So for example, suppose I want to evaluate minus 2 to the 0. Well, first of all, a is equal to minus 2 here. So it is a non-zero real number. And we've defined a to the 0 here. It's just 1. No matter what the a is, we have a to the 0 equals 1. Pardon me. 2 to the negative 3. Here we have a positive base. A is 2. And now the exponent is negative 3. So we have our exponent is negative 3. So according to our definition, this is a to the negative n, where n is positive. And so this is equal to 1 over 2 to the 3. And we define 2 to the 3 above. So that's 1 over 2 times 2 times 2, which is 1 over 4 times 2, which is 1 over 8. You might want to pause this video and see if you can figure out what minus 3 to the minus 2 is and what 1 over 3 to the minus 2 is. Okay, so hopefully you've attempted those, and we have minus 3 to the minus 2. Well, a is minus 3 here, so it's a non-zero real number, and minus 2 fits the category minus a positive integer, so we have a definition for this. It's 1 over minus 3 to the 2. And this is equal to 1 over minus 3 times minus 3. Minus by minus gives us a plus, and that's 1 over 9. 1 over 3 to the minus 2. It's just a little tricky. According to the definition, a is 1 over 3 here, so it's 1 over 3 to the power of 2. And that's equal to 1 over 3 times 1 over 3. And that's 1 over 9. And now, of course, according to the rules of fractions, we turn this fraction upside down, and we get that that's equal to 1 times 9 over 1, or just 9.